Good afternoon, everyone. Welcome back to the Scala session. Today, I want to talk about abstract data types and why we need pattern matching and various patterns in Scala and option types. Usually, a single type includes values of various structures. I'll show some examples. First, in real world, let's consider shape. Maybe you want to make some library for drawing, and then you should include various types. So first, there is a circle, and it is parameterized by its radius. And also, there may be rectangles, and you need width and height for rectangle. And also, you can draw lines, and you need starting point, so it's XY coordinate. Also, you need the end point. And you can think about vehicles. So maybe you want to model some traffic system. Then there are cars and motorcycles, and car have some wheel sit frame, and also motorcycle have the similar things like that. So in shape type, there are circle, rectangle lines, and in vehicle types, there are car and motorcycles. Also, in computer science and mathematics, you can find similar things. First, a natural number is either 0 or a successor of another natural number. So 1 is successor of 0, and 2 is successor of 1, like that. Also, you've already seen that list is either nil, which is the empty list, or cons, which is a pair of an element and another list. Also, you can construct a tree in similar ways. For example, so tree has nodes, which can be internal or the leaf node. So if a node is internal, then it has its value and its children. And if a node is leaf, then it will have only a value. So you can see that in natural number type, you have 2 constructs. In list type, you have 2. Also in tree type, you have 2. And also, if we narrow down into the programming language, and you can find similar things as well. First, you've already seen arithmetic expressions in the lecture, and an expression can be a number or an addition of 2 expressions or a subtraction of 2 expressions. And in this semester, you will learn lambda calculus in the course. And an expression of lambda calculus is either a variable or a function or a function application. So you may notice that these similar things appear again and again everywhere. A single type includes value of various structures. So, for example, arithmetic expression is a single type, and it has various structures. So we can use ADT or algebraic data type to express such types. So why its name is algebraic data type? So I want to talk about this one in detail. So basically, those types can be represented by sums and products of types. And in Scala, we implement ADTs by using case classes. So go back to our familiar example. arithmetic expression. You've seen this code already. So first we need to define type. So we'll say our type name is expert, and to define type we use this trait keyword, and I'll explain sealed after. And we have 3 variants. So each constructs are called variant, and number is mapped to this numCase class, and addition is mapped to add class, and subtraction is mapped to sub. And in more general, if you have some type and its variants, then you can implement them by using trait and case classes. So it's quite straightforward. And to use values of ADTs, you can use pattern matching. I know that you've also seen this code as well. And to use an arithmetic expression, you can use pattern matching. So you should write match first and open curly brace, and write all the cases and close curly brace. And for each case, you can write expression. So these cases are called patterns. So we'll see various patterns today. And it is a more general form, and yeah, you can follow this code when you want to deal with your own ADTs. And let's see why we use pattern matching. First, let's consider when we do not have pattern matching. Then we need to check whether a given value belongs to a certain type at runtime. For that, we should write this kind of code. You need lots of if-else branches, and in conditions, you should test the type of a given expression. And inside the body, you should typecast a given value to the type that you want. So in Scala, to type check at runtime, you use is instance of keyword, and to typecast at runtime, no, it's not runtime, it's just compile time code. To typecast, you should use as instance of keyword. And as you see, it's quite verbose and error prone. So it's very long, even though it does not do some real important things. And it is, you can miss some cases, and you may cast in correct ways. So this kind of code is considered to be error prone. On the other hand, if you use pattern matching, first, code becomes more concise than before. Also, if you use pattern matching, you have more advantages. Compilers will check correctness of your code if you use pattern matching. So it cannot guarantee the whole correctness of your code, but it guarantees some of them, and it'll help you debug your code. And also, by using pattern matching, you can express complex logic easily. So we'll see these 2 points. First, compilers can check exhaustivity of patterns. Let's consider this code. As you can see, we miss one case, which is sub. When you try to compile this code, the compiler will raise a warning like this. So it exactly points out that you miss this sub case, And because of that, when you run this code, you at runtime, match can fail. So when you see this code, you will notice that you miss some cases in your pattern matching, and you can revise your code before runs. And I want to note that to enable exhaustivity checking, you need a sealed keyword when you define your trait. And the next point is that compilers can check reachability of patterns. Let's consider this code. If you write duplicated patterns, and then when you compile this code, then compiler will raise warning that says there are some unreachable patterns. And it will point out where it is. So in this case, it will point this pattern because it is same as the above, and if E is sub of some expressions, then it'll go to this third pattern and the fourth pattern will not be used. So you can just erase this code. And in this very short code, it is very trivial that you made some mistakes here, but if you use lots of complex patterns and if your code is very long, then it is hard to find whether you have unreachable patterns or not. So compiler's check will be very helpful. Now let's see some various patterns in Scala. By using these patterns, you can express complex logic very easily. First, this code is not so complex, but it's nice code. So you may consider switch case of imperative languages, and you can do similar thing in Scala by using pattern matching. So you have constant patterns like this. So you may write integers or some booleans or strings as constant patterns, and if a given value equals to this constant, then the value will match this pattern and evaluate this expression. So this code is calculating a grade from exam score. And this wildcard pattern will match every value. So if score is not 0, 9, 8, or 7, then it just go through and it will match to the wildcard pattern, and F will be the result. And in advance, you can use OR pattern by using this bar, vertical bar. So it's somewhat similar to fall through in switch case. So if score is either 10 or 9, then it'll match to this pattern and A will be the result. And now we are going to see more interesting examples. First, let's consider nested patterns. So basically, you can use patterns inside patterns. So this code optimizes an arithmetic expression before evaluated. For example, you can optimize E plus 0 to E and 0 plus E to E and E minus 0 to E. So this code is doing that optimization. And so inside add pattern, you write num0 pattern again to check whether E has this kind of structure, and also they are the same. And also you can use you can bind some variables inside pattern. So let's assume that we add this abstract absolute value to arithmetic expression. So, and you know that if we compute absolute value twice, then it will be equal to computation of absolute value once. So you can change abs e to abs e, and we are doing that thing in the fourth line, fourth pattern. So basically you are checking that it is nested abs, but you need this part, not this part. So you use this @ symbol to bind e and bind this value to variable e, and you can return e here. And you can use type patterns as well, especially so when you are interested in only types but not the whole structure, then you can use pattern types. Here you are checking whether a given expression has type num, then it'll match this pattern, and you can nest type patterns inside other patterns as well, and also you can use wildcard here. And there are tuple patterns as well, and it's quite straightforward, so it will match to this pattern, and A will be 1 and B will be 2. And you can use pattern guards in patterns. So pattern guards mean some arbitrary condition. So let's consider such optimization. So if your expression has the form of n minus n, then it will be just 0. So first you check whether your expression is sub, and then you'll check whether both expressions are num, and the first value will be n, then the second value will be m, and you want to check whether n is equal to m, and so you put pattern guards here. So in general, you can write pattern if some expression, some Boolean expression, then if E matches this pattern and this condition is true, only in that case it matches the whole pattern and evaluate this expression. So that's all of patterns in Scala, and now I want to talk about options. An option is either none or some value. So it is another ADT, and it is implemented in Scala standard library. And so option type is very useful to express a result of computation that can fail. So you can return none if the computation failed, and you can return result inside some if it succeeded. And using options is a really type-safe way to handle erroneous situations. So there are multiple strategies to handle erroneous situations. For example, there are null values, null references, and exceptions. And null is source of a lot of problems and bugs, because if you try to deref null at runtime, then some kind of error like null pointer exception will happen and it'll crash your program. So Tony Hoare invented null references, and he said that he made $1 billion mistakes because null is the source of lots of bugs and it cost a lot. Also, you have exceptions. So when some erroneous thing happen, then you can just throw exceptions. However, in most type systems, exceptions are not checked by type systems. So when exception is raised but not handled properly, then programs will crash at runtime. That's very dangerous. And because of the problem, and some languages like Java introduced notion of checked exceptions. So it enforces programmers to handle exceptions by using try-catch. However, it's really verbose, and usually programmers do not handle them. They just use try-catch and throw unchecked exception again inside catch, so it's mostly useless. However, option is a type-safe way to handle errors. So let's consider some examples. We may want to calculate 100 divided by n safely, and you know that we cannot divide something by 0. So in this function, if a given argument is 0, then you will return none. Otherwise, you will return 100 divided by n inside sum. And you can check the function. Let's consider more. If you want to calculate the square of 100 divided by n, then you can use math method in option class. So first you call div 100 function, and you can map this anonymous function, which is a scaling function, to the result. Then if the result of this function call is none, then it will be this function will not be called, and the result will be none. And if some value is the result, then it will be called, and the result will be some value square. So you can check. And here we are going to calculate the factorial of 100 divided by n. And factorial is usually defined for only non-negative integers. So we are going to return none if n is less than 0, and otherwise we'll calculate the factorial. And here you can use flam map. So flam map is useful when the forced computation can result in error, and then second computation also can result in error. So here, if this results in none, then it will be none. If it is some value, it will try given function. However, if fv results in none, then final result will be none. Or if it results in some value prime, then it will result in some value prime. So you can check. And these are all I prepared today, and thanks a lot.